Hello teacher, my name is Sanjar Kusainov. Our final project is text classification for Kazakh social media content. We built a system that automatically detects whether a comment is toxic or not, specifically for Kazakh and Russian languages. The problem is real and relevant. Kazakhstan's online space is growing rapidly, so millions of people leave comment on social medias like YouTube, Tugis, Instagram, uh, and moderating all of them manually is impossible, so we created this system. First of our initial data sets we got from our friend. Here we have Tugis dataset, Tugis reviews for in Kazakh and Russian languages for medical center and public service center. Second, our inference dataset I parsed it from YouTube using YouTube API. I sent a GET request to YouTube to get a like count, comments, and comments IDs.
Hello, my name is Nordaulit Pegala. I was responsible for training models. Our first model is TF-IDF logistic regression with 10,000 features and Unigram and Bigram, where Bigram takes matter. They capture phrases like долгое ожидание, long wait, that carry strong sentimental on their own. The model is fast, simple, and fully interpretable. Our second model is XLM Robert A. It's fine-tuned model. Unlike the baseline, we don't need to engineer any features here. The model takes the raw text and handle everything automatically. We take this model from Hugging Face library, which this transformer pre-trained on 100 languages, including Russian and Kazakh, I guess. And we train our model on our dataset in Google Colabs T4 GPU because our laptop's resources are not enough for this task. Our model trained on 3 epochs, 16 batch size, and this kind of learning rate. Then our results became like this. Test split on TF-IDF is 90, XLM is 92, with difference 2%. When we use for test inference dataset from YouTube reviews, our TF-IDF became 75, XLM became 87, with difference 12%. And this shows that when you test data came from different source, the transformer handle much better than TF-IDF.
Hello teacher, my name is Aripa Yarasol and I was responsible for data analysis and pre-processing. Let me start with how to training data. For example, here we have as you can see here we have the chart, class distribution, negative and positive. They are balanced. We don't need imbalanced data. And here the chart sentiment distribution, text length distribution by sentiment, also top 20 negative force and the top 20 positive force. Also now here we have our data set. For example, here we have Almaty Gov data set. This is a review text, this is a clean text, also the sentiment about this, it's a training data. And we have the inference data, YouTube reviews. Here we have these YouTube reviews are short, emotional, and here we have it contains slang and the emojis that are simply not present in our like initial training data. So using cleaning, like here we delete all of them, we click the neutral sentiment that we don't need. Also we give the number 1 for positive, number 0 to negative, and we drop unnecessary rows, and we remove the like links, emojis, digits, and unnecessary spaces. Also we remove the stop words in Russian like i, na, and in the end we drop the duplicates that we don't need in our training data. That's all. Thanks.
So, hello teacher, my name is Nurdan Shamrat and I handled the metrics, predictions and dataset preparation. So our error analyses are that after inspecting the prediction file, we identified some clear failure patterns, and the TF-EDF model tends to misclassify comments that are contextually toxic but use neutral words. It simply doesn't understand context. So code switching between Kazakh and Russian is handled significantly better by XLM Roberta, thanks to its multilingual pre-training on both languages. So you can see here inference. And our practical conclusions are that we got a model with 87% of accuracy, So 87% accuracy is already useful for Kazakhstan YouTube comments, and as a first layer of content moderation, it can flag likely toxic comments for human review and significantly reduce moderator workload. And the same classifier can be adapted to monitor citizen satisfaction with government services on platforms like Tugis. And XLM Roberta's strong performance shows that multilingual transformers are a viable and practical solution for Kazakhstan NLP tasks, even when labeled data is scarce. And limitations we acknowledge that is the training data was obtained through personal contact, not from a public repository, which limits reproducibility, and manual annotation of YouTube comments is subjective, and we didn't compute an inter-annotator agreement score like Cohen's. And our future direction is that we plan to expand the dataset with content from Telegram and Vkontakte and explore Kazakh-specific models like Kazbert and extend the task to 3 classes, neutral, negative, and toxic, and add explainability tools like SHAP to better understand model decisions. So that's it. Thank you for watching. And all project materials like code, dataset, models, and results are available on our Google Drive folder. So that's it.